everybody. Today we're going to be working on calculating the volume of a prism. And just like we compared a cone to a cylinder, today we're going to be comparing a pyramid to a prism. So at first we're going to compare a square pyramid to a cube. Notice that the bases are congruent and the heights are also congruent. It might be kind of hard to see because they're transparent. You know, at the beginning of the year, I kind of stole, well, not beginning, but earlier in the year, I stole Cooper's bubonic plague. That's going to come in handy for this experiment. So I'm going to hold this up, and each time I'm going to pour some of Cooper's bubonic plague from this pyramid into the cube and see how many times the square pyramid will fit inside the cube. Does anybody have any predictions? If you do, write it down because it's probably a good prediction. Okay, so it might be hard to see at first, so I'm going to kind of show you what I'm doing up here. Right now I'm opening Cooper's bubonic plague. It's really old. Oh, it smells. Woo! Okay. I am pouring the bubonic plague into the pyramid. Okay. It's not quite full, but bear with me because I don't want to spill it on my carpet. Pouring it into the cube. Okay, so keep track with me. That was one time. Again, Cooper's bubonic plague, project for history that he tried to drink. I was able to recreate it. Props. Okay, and more of it. And we're gonna dump this one. That's 2. Cooper, this is disgusting. And the last one, do not drink this or try this at home. Do it with the paper, the beans, and the rice like I suggested in the notes. It's not quite full, but it's pretty full. Like I said, I don't want to spill it. And 3. I feel like I shortchanged myself because each time I was afraid to spill it. 3 should have filled it up. Gets us pretty close, but remember each time I was just a little bit short. If you take the 3 times as a little bit short, 3 is how many times the pyramid would go into the prism. So we are going to go ahead, and that worked for the square pyramid and the cube. But let's see if it works for all pyramids. I also have a triangular pyramid here and a triangular prism. So let's see if I pour 3 of these into the prism, if that works as well. This time I'll try to be more accurate and not be as concerned about spilling. So, oh gosh, okay, definitely won't be concerned about spilling because I just splashed it. So 1, two, and I could put a little bit more in that one. I really don't want to. And 3, and that one's quite a bit closer because I wasn't so conservative about spilling, but there's still a little bit at the top because I didn't fill it all the way up because of the spillage. But it's about the same amount that I left at the top of each of these to not spill. So 3 of my triangular pyramids also fit into my triangular prism. That works for every single pyramid and prism. If I had one, I could take a pentagonal pyramid, dump it into a pentagonal prism, and it dumped 3 times. So our formula for the volume of a pyramid is remember our formula for the volume of a prism. So the prism was, whoops, area of the base times height. Well, since every pyramid goes into the prism 3 times, the pyramid would just be taking the prism formula and dividing it by 3. It's cutting it into thirds. So it'd be the area of the base times height divided by 3. Again, that's area of the base times the height divided by 3. So it's the same relationship that the cone had to the cylinder, the pyramid has to the prism. Hopefully this video was fun. Thank you, Cooper, for your bubonic play, and have a great day.